Science. The principles of science apply to all matter in our universe and make up our very existence. The knowledge that we know today would not be possible without the contributions of thousands of individuals to the scientific world. The knowledge gained through their countless hours of research and study laid the foundation for the scientific knowledge that is still taught in the present day. Many key individuals have had significant contributions to the scientific world. Throughout human history, the contributions by key individuals have shaped the scientific world and the knowledge shared as we know it. These are their stories. Please note that the following skits you are about to see should not be judged as historical fact and are merely used to represent the ideas of each person in this video. In 4th century BC, Greek philosopher Aristotle made numerous contributions towards not only philosophy but also proposed early ideas about the physical properties of matter. This man, depicted here by local Asian Dean Oscilla, believed that every earthly object had a natural state based off of its composition of the 4 classical elements: earth, water, air, and fire. The strength of this natural state drawed objects to the earth. Because he felt that this natural state was dependent on the composition of the elements, he believed that heavier objects fell faster to the ground. Here is a comparison between a light pine cone and heavier water bottle. Notice how, without air resistance, the objects fall at roughly the same speed. We know now today that this is the force of gravity, and that each object has a free fall acceleration of 9.8 meters per second squared. Though Aristotle was completely wrong about heavier objects falling faster, he did pave the way for the eventual discovery of gravity and its universal effects on all matter. We now take our story to 1590s Italy, where Galileo Galilei conducted famous experiments such as the Pisa experiment, where he found that the time it took for objects to fall was independent of their mass. Another famous discovery made by him was the proof against geocentric theory, which said that the Earth was the center of the universe and all celestial bodies.
I don't care what it is, it's illegal.
But gentlemen, the evidence is right here.
It's against the teachings of God, so you're under arrest. You're coming with me.
As shown by that glorious demonstration, Galileo's mathematical proof of heliocentrism, or the idea that Earth revolves around the Sun, actually led to his condemnation by the Roman Catholic Inquisition and subsequent house arrest, where he spent the rest of his life. Though he spent the rest of his life in his home, his contributions led to leaps and bounds in the worlds of astronomy and classical physics. Knowledge that once led to his arrest and was a crime is now an integral part of the scientific community and is taught in schools around the world. Now, let's journey 100 years into the future, where we look at the life of one of the most, if not the most, important scientist in the world, Sir Isaac Newton. Isaac Newton provided some of the most grounded and useful scientific knowledge within his book, Philosophiae Naturalis Principia Mathematica. In this book, he provided the foundation for classical mechanics. This foundation is very important to humanity, as it has allowed for the expansion of physics and mechanical knowledge to get humanity to where it is today. Perhaps one of his greatest accomplishments is his proposed 3 laws of motion. Newton's first law, also known as the law of inertia, said that an object at rest would stay at rest, and an object in motion would stay in motion unless acted upon by an outside force. For example, a ball rolling on the ground would continue to roll indefinitely unless someone or something were to stop it. Someone were to stop it. Newton's second law stated that the acceleration of an object produced by a net force is directly proportional to the magnitude of that force. For example, throwing a football with a large force will produce a proportionally large acceleration, as shown. However, a smaller force will result in a smaller acceleration. Newton's third law stated that for every force upon an object, there would be a force of equal magnitude but opposite direction. Notice how the wall didn't move when the ball hit it. This is because the wall exerts an equal but opposite force on the ball when the ball hits it. This causes the ball to bounce off the wall and the wall to remain stationary. Now, let's journey to 20th century Europe, where the ideas of quantum mechanics truly took shape. The subject of quantum mechanics remains a mystery to scientists even to this day, but a lot of the debates about the topic have been famous throughout history. One notable debate was between one of the most, if not the most, famous physicists in history, Albert Einstein, and the man who proposed the model of the atom, Niels Bohr.
Science is based off of what is and facts, you idiot! Well, science changes all the time, so you don't know that. Well, come and show me then, huh?
Hey Klein, just wanted to take a moment to say thank you for your teaching and coaching, and that I'm glad you were my teacher. Perhaps in our lifetime we will find the truth about quantum mechanics, and the debate between Bohr and Einstein will be settled. This takes us to our last physicist, Richard Feynman. Though he may not be as well known as some of the other physicists listed in this video, his contributions may be the most important to us today. Though he was not the first to come up with ideas about quantum mechanics, Richard Feynman played an integral role in the foundation of the science as a whole, contributing great bounds of knowledge to it.
Hey, I'm Richard Feynman. An object released from the Earth's surface will fall 16 feet in 1 second. An object thrown horizontally will also fall 16 feet in 1 second. My law of gravitation states that a particle is attracted to every other particle through a force directly proportional to the product of their masses and inversely proportional to their distance.
Feynman is the father of quantum mechanics. Without his knowledge and research, the field of quantum mechanics would not be as developed as it is now, and for that we thank him. And there you have it. All of these physicists have made their own contributions to the world of science, but each of them has their own importance, and with their knowledge, our world is that much more educated. However, these are only a select few of individuals. There are still countless people who have made their own contributions, and countless teachers that have helped to pass it down. Hey Klein, just wanted to take a moment to say thank you for your teaching and coaching, and that I'm glad you were my teacher.